So here we are. Carl wishes to have an annuity that provides monthly allowance of $5,500 when he retires. So that's what he wants to make every month. He plans to retire at 64 and have enough money to last until he's 90. So if I go 90 minus 64, I already know that that is 26 years. Times by 12 months is 312 months in total. Well, that might be where this 312 comes from. And it's provided 4.73% compounded monthly. And so it says, show that P, the money required at 64, is given by this formula here, where R equals 1 is this scenario, R equals 1 plus. So this is the rate of return. So if we think about this, so what happens with this is the very first month we start off where Carl has P, and then he takes away $5,500. That is the beginning of the month. Okay, and then at the end of the month, what happens is this money, whatever is left, makes interest, the R interest. And so I know that I have PR minus 5,500 R. Well, then at the second month, what happens is I know then that this value here, I come along and I add, sorry, I don't add, I subtract 5,500. And then at the end of the month, all the money that's left here is multiplied by R. And so I have PR squared minus 5,500 R squared minus 5,500 R. And then month 3 comes along. So at the beginning of month 3, I have this much, and I take away 5,500 again because I need that to live off of. At the end of the month, all of this value gets multiplied by R. And so I get PR cubed minus 5,500 R cubed minus 5,500 R squared minus 5,500 R. And this continues on and on and on, and this happens for a total of 312 months. So if I bring this down, so then at the end of 312 months, I have P R to the 312 minus 5,500 R to the 312 minus 5,500 R to the 311 minus the very last month is 500 R. And then I'm all out of money. Everything is finished. And so then I have to add all of this up. Well, I know that I'm trying to show the money required is given by this. So I know that if I add all this up, I have to get 0. And I'm trying to solve, my key is I want to solve for P here. So if I'm going to solve for P here, I'm going to bring all of these terms over to the one side. And so I'm going to need to actually look at this sum here. And if I consider that sum, I could say this is P R to the 312. And I'm trying to get this to be true. And I'm going to pull out a negative. And if I pull out the negative, I know that I have 5,500 R 312 all the way up to 5,500 R equal to 0. If I go now, I'm going to subtract this whole thing here. Well, if I make this U1, I have 5,500 R times, well, each time I get multiplied by R, and there's 312 of them, minus 1, over r minus 1 equal to 0. And so I'm solving for p. So p, I'm going to bring all of this over. So I get, when I bring this over, I end up with 5500r 12 minus 1 over r minus 1. And then I have to divide by that, which is put it here, r to the 312. And that is almost there. The last step is I haven't got it exactly. I got 311 here. And so what the last step is, if you can see it, this r cancels away that, and I end up with 311. And so this is 5500 r to the 312 minus 1 over r to the 311 r minus 1. So that is a part. Hence, determine p to the nearest dollar. Well, now I know what r is. R is this value here, 1 here. So I plug that in here and I end up getting whatever the answer says. This number here, 99990 and 318. So again, it's this idea of building the equation month by month, year by year, to see what's going on.